In the last video, we discussed about solving linear equations using the graphical method. In this video, we'll discuss the algebraic method of solving linear equations in two variables using substitution method. Can you write this equation as an equation of y in terms of x? Absolutely correct. Writing in terms of x, we get y is equal to 9 minus 2x. In the previous video, we helped Rahul in finding the number of balloons and ice creams using the graphical method. In order to understand the substitution method, let's look at the pair of linear equations in two variables made by Rahul. We can divide the substitution method in three parts. In the first part, we choose one equation as per our convenience and express one variable in terms of the other. Like here, we take equation 1 and write variable y in terms of variable x. We can call it equation 3. In the next step, we substitute the value of y in the other equation. Like here, we have taken the value of y from equation 3 and replaced it in equation 2. By doing so, we get a linear equation in one variable. Solving this further gives us the value of variable x, which is equal to 7. In the third step, we substitute the value of x in equation 3 and obtain the value of the other variable. Like here, we substitute the value of x in equation 3. Solving further gives us the value of y is equal to 12. Therefore, x is equal to 7 and y is equal to 12 is the unique solution to this equation. Substituting the values of x and y in both the equations and solving them, we can verify that x is equal to 7 and y is equal to 12 is the only unique solution to this equation. Therefore, Rahul bought 7 balloons and 12 ice creams. Here, to solve the pair of equations, we have used one equation and expressed one of its variables in terms of another variable and substituted it in the other equation. And that's the reason this method is called the substitution method. In this video, we studied how to solve a pair of linear equations in two variables by substitution method. In the next video, we will look at some examples based on this method. Welcome to this video. In the last video, we learned how to solve a pair of linear equations in two variables using the substitution method. In this video, we will look at some interesting examples based on it. And we'll also see why we need the algebraic method for solving these equations. Solve the following pair of linear equations by using the substitution method. Do you remember that the substitution method has 3 steps? Can you tell what is the first step? Yes, we take an equation according to our convenience and express one variable in terms of the other. Here, we take equation 1 and express y in terms of x and denote it as equation 3. In the second step, we substitute the value of y obtained from equation 1 in equation 2. And solving it further, we get x is equal to 7 by 15. Now in the third step, we take the value of x obtained from step 2, substitute it in equation 3 and find the value of y. On doing so, we get y is equal to 17 by 15. we substitute the values of x and y in equations 1 and 2. And on solving, it can be proved that x is equal to 7 by 15 and y is equal to 17 by 15. This is a unique solution to this pair of linear equations. You can see that the solution of this pair of linear equations is not a whole number. When the solution of linear equations is not a whole number, then it is not suitable to use the graphical method, because the chances of making an error while plotting these points are high. In this situation, linear equations can be solved using the algebraic method instead of the graphical method. Let's look at another example. Solve the following pair of linear equations by using the substitution method. First of all, let's take equation 2 and write x in terms of y. Now, substitute this value of x in equation 1. And on solving, we get an incorrect equation without a variable. Can you tell me what it means? While solving the pair of linear equations in step 2, if we get a correct equation without any variable, then there will be infinite solutions to the pair of linear equations. And if we get an incorrect equation without any variable, then there will be no solution to the pair of linear equations. Because in this example, we got an incorrect equation without any variable, therefore, the pair of equations do not have any solution. In this video, we looked at some examples of solving linear equations in two variables using the substitution method. We also understood the importance of using the algebraic method. In the next video, we'll look at some commonly made mistakes while solving these questions. Welcome to this video. In the previous video, we looked at some examples based on solving linear equations in two variables using the substitution method. Now, we will look at some commonly made mistakes while solving such questions. Solve the following pair of linear equations by substitution method. To solve this question, pause the video and then match your answer. To begin with, take equation 1 and express any one variable in terms of the other variable. By substituting the value of x in the equation 2 and solving, we'll get the value of y as 1. By substituting the value of y in equation 3, we get the value of x is equal to 0. Therefore, for the pair of given equations, x is equal to 0 and y is equal to 1 is the correct solution. Hence, option 3 is the correct answer. If you selected option 1, then it was a good try, but this is the wrong answer. Because, while solving the question, you expressed x in terms of y in equation 1. Then, while moving 2y from the LHS to the RHS, you forgot to change its sign and solved the question based on it, and as a result you get the wrong answer. If you have selected option 2, then it's a good try, but this is also an incorrect answer. Because to solve the question, you expressed x in equation 1 in terms of y, and you replace the value of x in equation 1 only. This is how you got an equation without any variable. That indicates that the pair of linear equations has infinite solutions, which is why your answer is wrong. I hope you've understood why option 3 is correct and all the other options are wrong. Teachers can test their students' understanding in the class by using such examples.